sequence and series. Sequence and series are very closely related. In fact, the only difference between it is a sign. In series, you're going to add the terms together, and in sequences, they're separated by commas. Because a sequence is a pattern of numbers that are either finite or infinite. So what a sequence means is that you got these sets of numbers. A finite sequence versus an infinite sequence. Finite sequence means that it stops. So that one right there is a finite sequence because it stops at 4 terms. An infinite sequence is it goes on forever. And you have this ... So that is an infinite sequence. Okay. Some terminology here. Here are some terms in a sequence. They're separated by commas. I'm missing the commas, but 2, 4, and so on. Okay. N is where the number is in the sequence. So if n equals 3, we're talking about the third spot or position in that particular sequence. A with the little 3, A sub 3 is the actual number that you would see in the third spot. So if I go 3 numbers in, that number would be 6. A with the little 1 is the first term. And sometimes you'll see A with an n minus 1. That means previous term. Now, a general rule of how to write these things is a rule based on the number's position. For example, if this is the first spot, how would I get this 1 turned into a 2? If this is a second spot, how would I get the 2 to turn into a 4? Well, I notice that whatever my position is, if I multiply it by 2, that's the number that's sitting there. So if I look at n equals 6, or if I'm looking for A with a little 6, if I put 6 times 2 in there, I should get 12. And sure enough, the 6th number happens to be 12. So my general rule would be 2 times n. Okay. So if I want to write out the first 6 terms, so A sub 1, sub 2, A sub 3, A sub 4, A with 5, and A to the 6. So I would go 5 minus the 1 because of that 1. So 4. 5 minus 2 because I'm looking for the second spot. Okay, my rule is take 5 minus whatever your position is. So 5 minus 3 will get me the third number. 5 minus 4 will get me the next number. 5 minus 5, 0. 5 minus 6, give me a negative 1. So if you looked at this horizontally, 4, 3, 2, 1, 0, and negative 1 would be my first 6 terms. Okay, if you notice, they are all going down by 1. Or you could think of it this way, adding a negative 1. Well, this is a special type of sequence. It's called arithmetic, and we'll study more of them as we get along. But it's basically the slope of that line that's in front of that, so that negative 1. That's why you're going down by 1. Over here, okay, 5 to the first power, 5. 5 squared, 25. 5 to the third power, 125. I'm just working my way down. 3,125, I believe. 5 to the 6th, and yeah, I'm going to use a calculator. So will you is 15,625. Okay, those would be 6 terms. Well, you look at this, it's 5 times 5 times 5 and times 5. It's exponential growth, just like we got done studying. Okay. Yeah. So that one's called geometric, and we'll get to that one a little bit more too. All right, the first 6 terms. So So 5 plus 1 squared, so 6. 5 plus 2 squared, so 5 plus 4, 9. 5 plus 9, so that's 3 squared. 14, 5 plus 4 squared, 16, so 21. 5 plus 25, 30. Yeah, 5 plus 36, 41. This one doesn't add a constant number or subtract a constant number or multiply by a constant number, but it's still a sequence that's got its own rule. Okay, this one's a little bit different because now I'm going to base this off of my previous number or term. So if I start with my first one being 4, I'm going to get the next number by adding 3. Or if you want to see it this way, the first number is 4. To get the second number, I'm going to take the previous number. So the first number and add 3 to it. So I'm going to take 4 and add 3 to it to get 7. Now to get the third number, I'm going to take the second number in my sequence and add 3 to it. So 7 plus 3, 10. Plus 3 is 13. Plus 3 is 16. Okay, and then finally 19. Okay, this works out nice, but let's say I want to get the 100th term, it's going to be a little bit more difficult to get it out of there. Okay, write a general rule. So my pattern here is that I notice that the 2 stayed the same, but the 5's increased. It goes 5 times 5 times 5 times 5. So my next number is going to be 2 over 3,125. How did I get that? I took 625 times 5. Okay, so my pattern is that I'm going to multiply the denominator by 5, or I'm going to kind of cheat and go, the 2's stay the same, and the denominator is 5 to the nth power. Okay, my pattern is that I'm going to add 2. Looks like I go up 2, up 2, up 2. So the next number is going to be 11. So what I'm going to do is, I'm going to say I'm going to start off with the first number, and I'm going to take my previous number and whatever that previous number is, I'm going to add 2 to it. So that's some general rules for sequences, not so much series. We'll talk about those later.